Good morning. We are RS 2020, sponsored by Landera Group, featuring flexible fixture systems, cut fixturing time and a half. My name is Justin Romero. I am the process engineer. I'm representing all of Rowdy Science 2020, as well as my members, Rudy Melendres, who's our project manager, Osmar Perez, who is our design engineer, and Drew Tickham, who is our analysis engineer. We're going to kick off everything with our background.
The problem that we were presented with was soft jaws were expensive to manufacture and add little to no value to the workpiece. The setup time is more than 30 minutes or longer. Also, it wastes a lot of material that adds more expense to the bottom line, especially if you're just fabricating custom parts or components. We needed a way to hold workpieces that did not have to constantly be machined and that doesn't waste raw materials and time. Our solution for this was to have pins conform with a part's geometry as it is being manufactured in a CNC mill. The pins are being pushed by compression springs and are held in place with locking screws in the rear. These screws also offer additional force if needed on the manufactured part. Along with this, dovetails would be utilized on the top plate seen in the image as they are used for holding and alignment during the first operation, and just alignment in the second operation, as the pins will likely absorb the force of the vise and conform to the part. In this FEA analysis done in SolidWorks, we assumed that a single pin would see about 1,000 pounds of force and held in the rear. We chose carbon steel as the material as the yielding strength is 41 KSI and the maximum stress seen on the image to the left is 26 KSI and the maximum deformation, which is seen on the right, is 0.001308 inches. This is a part purchased from McMaster-Carr and it was the most viable option as other test materials would be crushed when compressed.
All the non-commercial off-the-shelf parts were made on the Haas VF1 CNC mill. On the left, you can see the Haas VF1 CNC mill. On the right, you can see the custom parts that were manufactured for the dovetail fixture. Here is the final product. On the left, you can see the assembly of the fixture. On the right, it is shown being tested with a square part. Here is the first operation. The dovetail feature locates and clamps the workpiece during the first operation. Here's the CNC mill cutting the first operation. Here's a closer look at the dovetail clamp feature. Given that the dovetail feature is square to the axis of the machine, when it clamps onto the stock will also be square to the axis of the machine. Below you can see that the first half of the sample part has been cut out by the CNC machine. Machining a part on the CNC machine is sometimes like making a pancake. You make one side, then you turn it over and make the other side. Here you can see that the first half of the finished part has been made. It is time to flip it over and make the other side in the second operation. During the second operation, the dovetail clamp locates the part before the pins take over and hold onto it. The dovetail clamps can be removed if they will be in the way of the machine's tool path. In the upper right-hand corner, you can see the pins holding on to the part of the workpiece that has already been machined. The dovetail clamps have been removed and the workpiece is held in place by the adjustable pins. On the right, you can see the second operation of the workpiece being machined on the CNC mill. This is the center of our design. The CNC fixture that required no additional machine to create is holding a sample workpiece that has non-rectangular sides. A workpiece like this could not have been held with conventional vise jaws.
In short, the dovetail fixture system is not entirely a soft jaw replacement, but rather an alternative to the widely used method within high-mix, low-volume shops, more so as an additional tool in a machinist's arsenal. So if a shop had to make 1,000 parts, they deploy durable tool steel jaws. If 100 parts needed to be made, maybe aluminum jaws would suffice, but if one part needed to be made, then the dovetail fixture would be deployed. Lastly, we'd like to improve in 3 areas: rigidity, flexibility, and automation of setup. During testing, a good amount of chatter and vibrations were seen, and we'd like to mitigate this by implementing stronger materials, limit the range of motion of the swivel feet to the z-axis, and shorter pins. To increase flexibility, we'd like to implement adjustable dovetails. We'd also like to add ball screws into the locking screw mechanisms to facilitate setup even further. And that is all, folks. Thank you guys for being here today.